Using smart contracts, we are able to build decentralized Web3 applications, also known as dApps. Decentralized applications are applications that run on a P2P computer network rather than on a single computer. dApps have existed since the advent of P2P networks. They're a type of software program designed to exist on the internet in a way that is not controlled by any single entity. There is no central point. So decentralized applications don't necessarily need to run on top of a blockchain network. There are many examples of decentralized applications without blockchain, like BitTorrent, Popcorn Time, BitMessage, Tor. They're traditional dApps that run on a P2P network, but not on a blockchain. Actually, blockchain is just a specific kind of P2P network. But in our definition, dApps are blockchain-enabled websites, where the main business logic, not the whole logic, works on a blockchain using smart contracts. It also has a user interface to allow users to interact with it. With it, let's start coding and let's take a look of a write code. Wave Smart Contracts language write has two types of functions: callable functions and a verifier function. We are already familiar with the verifier function. We used it for smart accounts to set rules for outgoing transactions. So for now, let's talk about callable functions. Here I have an example of write file, wallet.write, from the library in the online IDE. As you can see, there are two callable functions. These callable functions can be called by other users, not only by the dApp creator, for example. As a result of the execution, new information can be inserted or updated in the dApp data storage, in the key value storage, and funds can be transferred from the dApp balance to the caller or to another address depending on the dApp's logic. Here we have an example. This deposit function writes some data in the storage. Withdraw function writes some data and also transfers tokens. Great. In the next version of write, with write v4, tokens issuance, reissuance, burns will be also available as a result of callable invocation. But for now, let's talk about the current version of write v3. So users are able to call callable function in a process called invocation. Callable functions can be called using invoke script transactions. So we can find an example of invoke script transaction here in the test file. So you can do it right inside online IDE. So also these functions can use data about the blockchain, current height, about different types of attached information to the invocation. For example, this variable I, which is invocation, can contain details about payment, about currency, about the token attached to the invocation, about caller's address, public key, and so on and so forth. So let's try to implement a callable function in our Coupon Bazaar dApp example. Let's implement purchase function. Here I have it already implemented. For this, we have to understand how this purchase function works. So this purchase function should allow a customer to call this function, attach some Waves tokens, and if everything is okay, if user paid as many tokens as we expect, then we have to write some data in our dApp storage. For example, we have item A, and we expect that item A price is stored in the dApp storage with the key item underscore A underscore coupon underscore price. Great. Now, let's go line by line through this function. we have a PMT variable which extracts a payment from the invocation. So in this variable, we should have all the details about attached tokens. For example, we can check an asset ID of the token attached to our invocation. And if there is no asset ID, it means that user attached waves. So we will accept only waves. Otherwise, we will just throw an exception. Great, we have our payment details. Then we can get customer's address. This I variable, this invocation, contains caller. From the caller field, we can get bytes and get base 58 string from those bytes. And using customer's address, we will store details later in our DApp storage. How to get a price? We have a function called getInteger, and we read from the key value storage of this DApp by the key, we read the value. If there is an integer, we take that value. Otherwise, the price is 0. Then we check that user attached as many tokens as we expect. We get amount from the PMT variable, which contains our payment. If this amount is lower than the price in the DApp storage, then we throw an exception that purchase amount cannot be less than item price. If it's more, then we throw an exception again, but with another message like purchase amount cannot be higher. Let me fix it. Otherwise, everything is okay, and we just write 2 key value pairs. The first key is status for this item with the customer address, and we set it as confirmed. The second key is a price, and we just store for what price this user bought this item. Let's go back to the JavaScript file with the test. Here we have one very simple test which just invokes a script, invokes a function. Here we define dapp's address or alias. For example, in my case, it can be 3p something. And we set which function we want to call, and we also set arguments we want to pass to that function. And also we can attach a payment. In our case, we attach waves because asset ID is null. And with this amount, we sign this transaction using Alice's seed, and we just broadcast this to the blockchain and wait for the result. That's actually it.
So these are the basic aspects of smart contracts and their implementation in Waves. I know you might have many questions about Write, its syntax, and how it works. So the best way to start learning Write is a Write introduction repository. I'll provide a link in the description below. There is also a GitHub repository with code examples written in Write. Also, you can use online IDE to see that examples. So all the links to both repositories to online IDE can be found in the description of this video. We wish you good luck with the code challenge.